Hello there, it's Jay here from Jay's Vintage Junk, and today I thought we would tackle the power supply out of Mildrids Ashtray, the Project BBC Micro. As I said in the previous video, what I thought I'd do with this is I've got one of these retro computer shack capacitor kits for the B power supply. So first thing I'm going to do is I'm going to install this, and then we'll have a go at powering the power supply up and see what voltages we've got coming out of it and how close they are to how they should be. And then what I've got, as this arrived in the post for me the other day, and I put a CPC order in, and I've got basically replacement capacitors for all the other electrolytic capacitors in the power supply, and these are all decent quality. I spent a little bit extra and went for more premium parts, so they're all Panasonic. So they're all Panasonic capacitors, brand capacitors. They're not cheap, no brand stuff. I've got all the ones I need in there. I've actually basically I've bought double because I am going to do the power supply in my beeve that I use as well, because it really does need the power supply recapping in that. I do know there's a few caps on it which are not in the best of conditions. I thought I'd just do on this one just as a trial, just to show you guys anyway. Let's see what difference it actually makes changing all these other electrolytic capacitors. But I said the first thing we'll do is we'll put the retro computer shack capacitor kit in. I'm going to use as simple tools as I possibly can for this. I've got my ancient soldering iron heated up, I've got a cheap meter, I've got a cheap solder socket, a couple of basic screwdrivers, cheap pair of cutters. I'm not going to use anything fancy at all, just to show that you don't need really expensive tools to do a simple job like rebuilding one of these power supplies. So we might as well get on with it. But first thing we need to do, actually, we've got a cable tie there. We need to snip that cable tie off. Have we got another one about anywhere? I can't see another one. We definitely had that one there that would stop them wires coming free, so that's okay, that's free now. The next thing we need to do, another cable tie just up there which is holding the line and neutral wires there that come in on the mains flex to the top of that switch. And there's a little tag on the top of that switch that we need to depress to actually remove the switch. Basically, if we don't take the switch out, there's two ways of doing this, the proper way and a naughty way. The proper way, which is the way I'm going to do it now, is to actually take that switch out and then you can manipulate the board out of the metal case. The naughty way of doing it is to bend the metal case, pull the board out, do the work and then bend the case back, but you never ever get the case perfectly straight. I've seen loads that have been done like that because people couldn't be bothered faffing getting that switch out. So we'll snip that cable tie there. I was wondering why they put two cable ties in the kit, and that's it's just dawned on me now. So it's not a bad kit really. We'll see whether, like I said, doing all the extra work really is worthwhile. I think it probably will be, but like I say, if you've got a B power supply that's emitted smoke, that's basically the minimum you need to get yourself back on the road. Right, so we've got them two wires free there. We'll pull them free from the switch. See if I can just get in with my snips and help slide that connector off there. There we go, that's the first one off. I'll try doing the same on this side, although its access is a little bit more restricted. I think I pulled it free enough that we can probably manipulate that off. What you don't want to do, and you see a lot of people do it, is get hold of the wire there and pull, because you risk actually damaging the crimp. they should really always hold on to the connector, or use a screwdriver or something to help slide it off. That's come free. Just be able to pull that out. There we go, that's out. So that's them two out. We've got the returns to the board there, the red and the black, so we need to disconnect them. Let's see if we can do the same thing. If we ease that off. That's that one off. This one might be a bit tricky to get to. We might have to get a little flat blade screwdriver to help out here. We might be able to get in. Let's see if we've got a little flat blade screwdriver to help get that off. I think I've got one down here. There we go. We'll get that in there like that, and we'll just I'll just pop that connector off. It's been a bit stubborn, this one. It's always the one that's in the most awkward place is always going to be the tightest one on there. I think that just released then. Let's spin it round and see if we can get in. Pop, there we go, that's off. Pop that off, pop them two out of the way. And now we can get that switch there out of the way. And basically, I don't know if you can make this out. Let me see if I can zoom you in just to show you. I'll get you down a bit and see if I can zoom you in. Right, what's the best way I can orientate this? There we go. If you can you see these little plastic tabs there at the top and the bottom of the switch? There's 4 of them. And basically what we need to do is push them in while we draw the switch out. They're quite tricky because they're actually quite stiff. I might have to get another couple of screwdrivers. What is usually the easiest way of doing it, if you push the top 2 down first, and you can hold them down with something like that, and then we get another screwdriver in and hold that one down, and then we get a screwdriver there. We can slowly lever the switch forwards and then just winkle the bottom 2 out, and hopefully we'll be able to get the switch out without damaging it. I've usually got these switches out without doing any damage to the switch. There's only been perhaps 1 or 2 where I've slightly mangled the switch, but even so, the other switch has still been usable. I've just perhaps broken one of these tabs. We'll push that down like that. I'll zoom you out a little bit so you can perhaps see a bit better. So I've got the 2 top tabs pushed down. I'll get a screwdriver or something into the front of the switch. Just draw it forwards. Oops. Try not to slip and hit the board. And I'm not going to edit this video. If I struggle to get this switch out, you're going to have to sit there and watch me struggle to get in this. There we go. The first half of the switch out. So basically what I do is put a bit of pressure on the back of the switch with my thumb there, and just push the 2 tabs left and right down, and it's popped out. And as you can see, it's just popped out. Hopefully we can do exactly the same thing on the other side to get the other side of the switch to pop out. And I don't know if you're going to be able to see this as well, but basically I'm going to put my finger on the back of the switch and I'm going to get the screwdriver in and just push them tabs on the switch down. That's the top one down, I think. There we go. That's them out, and then there should be another one on the bottom, which is going to be the tricky one to get. We've got the top 2 out now. Let's see if we can get the bottom 2. Push that one. Get in there, and hopefully you can see what I'm doing. So it really is just a case of pushing the tabs in. There we go. Nearly out though. It's tab at the top's now stopping it coming out. Hopefully we can. There we go. That's out. And we're out. I know that's a bit of a faff. That's why you see a lot of these with the chassis bent, because people don't want to go to all that faff just to get the switch out. So anyway, we've got the switch out. Next thing we need to do is disconnect this earth here. We get the pliers, and there's just there's a nut on the back of it, so we hold on to the nut, give it a twist. There we go. That's the nut off. Screw out. That's the mains lead disconnected completely with no earth connected there. We've got that earth that goes to the main board there disconnected. Little star washer there, we won't lose that. Right, next thing, we've got another earth on this side also here that we've got to disconnect. Again, if we just hold on to it with the with some pliers or something. Take this screw out. There we go. We'll give a quick shake, get that washer with just... There we go. Because that's what happened with my other power supply. We got a little foreign object like that under the board, and it shorted. So I was very lucky in that respect where it shorted. Next thing we need to do is we need to release this connector here. That's what will go to like an external disk drive. It's to power external devices off the actual beam. So we need to release that. And again, it's very like the switch. It's got some tabs on the side. If we push them in, sorry, on the top. If we push them in, we can just work this into the unit, and it'll just pop in. It's actually a lot easier to do than the switch. That's the top one's pushed in, but it's exactly the same procedure really. Just push the little tabs in. Of course, this one will now fight because I'm doing it on the video. These usually come out quite easily compared with the switch anyway. Come on. Watch this one take me longer than the switch did, just to spite me. There we go. There we go, that's the bottom pushed in proper. Just do the same to the top. That one side in, that side in, and there it is, popped in. You don't want to be too forceful with it because you do need them tabs to remain intact. Especially if you actually want to be able to use that. I mean, I don't really use that on mine. Where I do use a disk drive, it's got its own internal power supply in it. And obviously if I'm using a modern storage solution, you're not using any power anyway, really. Oh, excuse me. Right, so the next thing we need to do is actually get the board out of the case. So, let's get over to the Phillips, and unfortunately they put like a sealing compound on a lot of the screws in these, and you do have to basically chip it away to be able to get the even to get your Phillips screwdriver in to start getting the screws undone. Whoever did this one was very enthusiastic on the sealing compound. They've absolutely filled the heads of the screws. So we'll have to just do a little bit of digging, I think, on especially on this screw. I think some of the other screws are better. It's just this one they went to town on. but there we go, it's surrendered. Right, that's that screw out. Let's have a look. Doing the others. Right, so that's that first one out there, and that again has a little washer, so we won't lose the little washers. We've got one here. And that's that one out. Does that got a little washer? Yes, it has. Oh, I'll pick this little washer up. There it is. Now, there's another. I think it's 3 screws on these boards. Yeah, I'm pretty certain it's 3. Again, they didn't go mad with the sealing compound on this one. Just that first one. Okay, get that out. And we'll just recover that little washer. There it is. Put that to one side, and now hopefully we can extract the PCB nice and easily. Now, if you don't take the switch out, you can't just slide the board out like that. We'll take the case and the cable and just put them to one side for a minute, and we've actually got the PCB out now. We can actually look at it properly. And I mean, it doesn't look in bad condition actually. I can't see any scorch marks or anything like that on it. It doesn't look bad at all. It has the obvious, spin it around this way. It's got the capacitor there that's bit the dust. It's got another capacitor there, that 0.01 UF, which is also likely to be one to fail. There's a 220 UF back there. Excuse me. Electrolytic, which I also believe is quite a common failure point on these. I mean, it won't emit the magic smoke, but it will stop the power supply from actually working, I believe, if that fails. We do have a replacement for that in the retro computer shack kit, because that must mean it is a very common one to fail. Anyway, first thing we're going to do is we'll change out these 3 capacitors, and then I said we'll power this supply up, and we'll have a quick look at how it's actually running like that, and then we'll look at replacing the rest of these electrolytics. So I think we'll start with that one I've just mentioned, that 0.01 UF. I know it's not the one that's failed, but I don't want to leave it in there, so it might as well come out. Just heat up the joint, get the old sucker in. There we go. Spin the board back over, and we should just be able to lift that straight out now. Yeah, that was definitely the next one to go. Don't know if you can make it out on the camera. Come on, focus. But it's starting to crack, and when they crack, basically they let moisture get inside. Obviously the moisture starts breaking down the capacitors layers in there, and they eventually emit the magic smoke. So we've got that out. It's a shame actually, it is exactly the same type of capacitor they give you as a replacement. Yeah, it's a Weimer. Exactly the same technology, but it's like 30 years newer, so hopefully that'll give us another 20-30 years before it causes problems again. So we'll stick that in the board. And obviously it's exactly, this is the nice thing about these retro computer shack kits. There's no messing about bending pins or anything, it goes straight in the board like that. And what I'll do is I'll just very, very slightly give the pins a quick tweak over. That just holds it, just to hold it in position while I get the solder, and we solder it in position. Is that side done? That's that side done. Yeah, they're nice, neat connections. Right, so I'm happy with that. That's well on there. We may as well do the culprit, which is that one there. That's the one that actually blew and emitted the magic smoke. So that was before I owned this particular bead, but it's definitely gone. Right, hopefully that'll come out. Give it a little prod. It's perfectly free, it's just a little on the tricky side to actually to get at it, to pull it out. Even with some long nose pliers it might be a bit. There we go, out it comes. You can see that one really did go with a bit of a pop. Interesting thing being though that the bits of capacitor that I found in the case I don't think came from this this particular capacitor. So possibly this isn't the power supply that was originally in the computer. Anyhow, we'll put a new cap in there. Even though this capacitor is very slightly smaller, the lead spacing looks to be just the same. So, and the value is exactly the same. It's just the fact components have got a little bit smaller. Come on, where's the hole? There we go. Just push that into push that home into place. There we go. That's holding in quite nicely. We'll solder that into place. That one there. That one there. Snip these leads off. Okay, get rid of them. We don't want them shorting out on the board. Give that a quick shake off. That's that that capacitor replaced down there now. So all we've got from the kit is that electrolytic capacitor there, which, let's just have a quick check through, is, I believe, those two leads there. Right, we'll give that a quick wiggle and make sure we've got at least one leg then. We'll get hold of the capacitor and give it a quick shake. No. Let's I don't want to solder that up just yet because it's not moving because I haven't got enough enough solder off it. Let's try and take the next one out. Unfortunately, what they seem to have done when they soldered some of these thinner leg components in position, they actually laid the leg flat, which makes it really horrible to get the leg out. I'm just going to get a very fine flat screwdriver. and I'm hoping I can just heat the pad up and lift the leg up. And once I've got it up a little bit, hopefully I can wick the rest of the solder off from around it. There we go, we got it up. I think that is probably one of the capacitor legs. Right, let's give that a try. Yeah, so that was definitely one of them. That's free now. You just got to figure out which the other one was. It's that one there. So I was a little bit far out when I was guessing which leg was which. So we can happily solder that one that I made a mistake first off on, which is that one. Put that one back. There we go. And the one we need to remove, and again it's been laid flat, so it's going to be a bit of a pain to get out, but it's this one here. Okay, if we just heat it up a little bit, we should be able to lift it. At least enough that we can, there we go. We should now be able to get that, yeah, that's the capacitor now loose. Let's just note which side's negative, which is that way. So towards the back of the desk, we'll rock it out. Oops, we've lifted a pad there. That's a pain, but we can easily address that. It's not the end of the world. We'll get the pliers on that and we'll pull the little bugger out. It is completely free, it was just a bit stuck in the hole. The reason a pad got pulled then is I was trying to lever it, I got that leg out of the actual hole, and as I levered it, pushed back into the hole, and it actually caught on the edge of the pad and pulled the pad with it as it pulled back through the hole. It's a bit annoying. Like I say, it is savable, it's not the end of the world. Anyway, that's out, that's the 220 UF. It's a 10 volt, and they give us as a replacement, where is it now? I've lost it. Oh, what have I done with the new bloody capacitor? I forgot some actually. This isn't out, because I seem to have misplaced the one that came in that kit, but I'm pretty sure I've got some here. Oh yes, I have, and they're even better ones. They're actually a better quality capacitor, so we'll use one of these. I think these are. Can't see the make, but they're a decent one anyway. So we'll stick one of them. We'll stick one of them in. That's a bugger. What have I done with that? Never mind. Unfortunately, it is marked on the board where plus is, so we'll stick the new capacitor in there. Oh, and I've missed the pulled that pad up again. I have to hold the pad down with my finger and put the leg, so I get the leg through the hole of the pad. So we should be able to easily fix that. We'll push that down, bend it over, and it's that pad there basically that we've lifted. A little bit annoyed about that, but it's an easy fix fortunately. And the way I'm going to fix it is how this was soldered in the first place. I'm going to cut the leg now before I actually solder it in place, like that, and I'm going to lay the leg down flat like that, and then when I solder it in, it'll hold that trace that we've lifted in place, and it won't be an issue at all. A little bit annoyed about doing that, but it can happen. There we go, that's that fixed perfectly. Let me just zoom you in. Let's see if we can, are you on the, where is it now? Yeah, you can see the leg there, and then that there is where basically what I've done is I've bent the leg over, and I just soldered all the way across, so it's actually bridged onto the next point there. That's not going to come loose, that's absolutely fine, and we can just solder this one. We can solder this one in the normal way. So we'll just go in with the solder and there we go. We'll snip that off. Oops, you can't see that, can you? We'll snip that off like that. And there we are, that's good as new. Right, let's get you out a little bit. So what I think we'll do is we'll do like I said, and we'll have a test of the power supply while it's in this this state. Like I said, we've changed the capacitors, which obviously cause the emission of the magic smoke. In fact, have we got a good fuse in it? Seeing if it's blown the cap, it could have blown the fuse, but we'll just quickly check that, make sure the fuse is okay. Just put that there. Quick check of the fuse, and the fuse is fine. So we are okay to try this. Now, what I'm going to do now, I cannot recommend anyone try, because we're going to run just the bare board like that out on the bench, and we are going to be connecting it to the mains. So like I said, I cannot recommend anyone else does this. I am quite experienced with working with these things, so like I said, I'm not worried about what I'm doing here, but I cannot tell people to you know, replicate what they see me do. So I've got that connected up like that, and we'll connect. Sorry, that was my computer. We'll connect live to the red. We'll connect neutral to the black like that. So we've got the switching circuit. I've got the mains lead with the 13 amp plug connected up. I'll grab a nice beefy crop clip. I've got a nice big chunky crop clip, and what I'm going to do is I'm going to connect from the earth, incoming earth there, to that earth point there. So there is at least an earth going to the switch mode power supply. I'm guessing some of this metalwork may be earthed on it, I'm not sure, but I'd rather have something there. Right, we'll get the meter connected up. I've got a very simple, just see if I can get, in fact if I bring you down a little bit on the tripod and then tilt you up a little bit, you should be able to see the test meter there. There's a cheapy crappy one. We'll set that to the 20 volts DC range. We will just connect that up to a ground, and I'm going to connect that up to one of the 5 volts connections on the power supply, and we'll see how close to 5 volts we're getting out of it. Like I said, all we've done is change them filter capacitors and change that one electrolytic, like I said, which I think it's a case of if it goes short, it can stop the power supply from starting up. Like I said, it is a switch mode power supply. There's a big switching transistor there. Right, so that should be good enough for a connection. I'm not 100% sure which position that switch is in. I could test it, but I think it's more fun if I just put power up this thing and you see if the meter switches on. So what can I unplug here? I'll have to unplug that. So let's see. Like I said, it may come on now here, it may, I may have to switch the switch, we'll see. Anyway, let's power up to it. Let's flick this, well nothing's come up on there. So let's flick the switch and see if anything works. Well, we've got 5.04 volts there, so that's not bad at all actually. That's not really, it's not bad. Let's test a couple of the other voltages. We should have a -5 volts, which I do know on my power supply is quite low. It's only about -4.5 volts. So let's see how this one's faring for its -5 volts. It's even worse than mine, -4.35 volts. Like I said, we'll see if changing some of these capacitors is going to get that a little bit better. But the actual 5 volts rail, 5.04, and remember we've not got a load on it, there's no load on this at all, we're just seeing what the offload voltages are. Although being a regulated power supply they should be fairly close. We should have, I think, 5 volts and 12 volts on here. Let's give that a quick check. So, oh, we've got the -5 volts there. We've got 11.4 volts there. So it's a bit low on the 12 volts. The 5 again is fine. It should be the same as the other one, and they should be the grounds at the bottom, which they are. So I'll switch that back off. Safety first and all that, and we'll get that unplugged. But as you can see, it seems to be functioning actually okay. It's basically functioning about the same as the one that's in my working BBC Micro. The only thing I would say is that the -5 voltage did seem a little bit lower, not by much, but a little bit lower than it did on it does on mine, and I'm not happy with it on mine. So that is something I'm going to address. We'll see. These are tight. Let's see if we can scrape them off with this. I have got this unplugged now. I did definitely unplug the mains cable. Pop these connectors back off. Then we can get that out of the way, so we've got the board to work on. Come on, slide off. Come on. There we go, that's off. Lovely. So let's get, we don't need that on there anymore, we can get that out of the way. Right, we're back to the main PCB here. Let me get you perhaps down and zoomed in a little bit. Now, we've just had mains applied to this. Most of the capacitors on here we don't need to worry about, apart from those two there. Those basically are the they can hold a couple hundred volts charge on them. All the other capacitors on here are relatively low voltage, 16 volts, 25 volts, that type of thing. Those are rated at 250 volts, and they can store a charge which can give you quite a nasty crack. We do want to make sure that those are discharged before we start actually messing about with this thing. Hopefully, with the age of this thing, there should be some bleed resistors on here that will basically bleed the voltage away from them as soon as the power is disconnected, but you can never be too sure. You always want to make sure that those high voltage capacitors there are discharged before you start actually messing about with this thing. So with that in mind, we will very carefully turn it over, and basically it's them connections there that we need to be worrying about. I'm just going to, actually with the meter, let's see if we can get the meter so you can see it as well, and we'll actually see what we've got on them. Where can we get it where you can see the meter and I can see the meter? There we go, you can see that there. Now, this is the first capacitor, so if I put That's on the ground side of it. Unfortunately, yeah, there is nothing in that capacitor at all. There is some form of discharge resistor, because that's completely gone, completely dead. We'll go on to the other one. We'll just check the other one just for completeness. But yeah, we are completely dead there. And we won't just leave it at that, because there could be, my meter could be faulty. There could be something wrong with that meter and it's not actually showing. So before we actually handle them two capacitors, what we're going to do, that one's a good one to use, we'll take a screwdriver that you're not too bothered about, and basically what we're going to do is we're going to short out across the... if I wasn't going to replace these capacitors, I wouldn't do this. I'd use a bleed resistor and bleed the capacitors, but these capacitors are just about to be replaced. I'm not worried about them, so I'm not worried about if there was a charge in there, me putting a dead short across it, because if I damage the capacitor it's being replaced anyway. But basically what we do with extreme care, just take a screwdriver and just short across the two capacitors like that, the two terminals on the capacitor. Like I say, if there was any charge in there, you get a bit of a crack and a flash, and it'd be gone. And again, with this capacitor, we'll do exactly the same. And no, they're completely discharged, so I'm happy to touch that. It's safe. Right, let's start with these two high voltage capacitors. We might as well get them out in the first place. So again, it's annoying. It's just the way that they've really done this board is a lot of the thinner leg stuff, they seem to have cut them short and folded them over and then soldered them, so it does make getting them out a little bit harder than usual. Hopefully we can get a lot of solder off them. They won't be too bad to get out. These big ones especially, they might be a bit easier. Let's give that a little rock. We may have to heat them up again and see if we can lift them. So that side's free there. The other side, however, is being a little bit more stubborn. Just try and remove a little bit more solder from it. Let's give that a try. There we go, that's free now. That's free, let's get that out. That's the first of them electrolytic capacitors out. We've got to remember which way the neutral is, the negative is, sorry, so we'll remember stripe towards me. And if we remember stripe towards me, we can't go far wrong. So they're okay. Let's get the next one out. This one's hopefully going to go. I was going to need another suck. There's quite a lot of solder on this side. There we go. Let's give that a quick whittle, see if that's come free. If not, we may have to go back in and add a little bit of fresh solder. Yeah, let's go in and add a little bit of fresh solder and try a new suck. There we go. Let's give that another go. The new solder basically just helped the last of the old really nasty solder just to flow, so you get the joint clean. There we go. Let's try that now. What we might have to do is just give that a quick heat up. while we draw them out. There, that side's up. That's up. Sometimes you do have to walk them out. Come on, out you go. There you go. Just clean the, make sure the holes are clean, which they are. Excellent. Oops. Come on, Ian. Get back in your stand. There we are. And there's the two offenders out. Now, where's the new ones? I think these are the 450 volt, sorry, not 450, 250 volt, 100 UF. Yep. So if you can see, as I was saying, they are a little bit actually physically smaller than what they're replacing, but they're exactly the same value, the same spec and everything. It's just that's what's happened with technology. You know, technology has gone on a little bit. So let's get these in the board. That's the first one in. Fortunately, you can't go too far wrong because the plus is marked on the board. But it's always good practice just to make absolutely sure, you know, if you can remember which way the old one went round. It's obviously it's easier. Right, so that's them in situ. Oh hell! And we've done it that side as well. You can see there we've lifted a. As I pushed that capacitor through, it must have just caught. Because I mean the hole was perfectly clear. It's just caught and lifted. We'll do exactly what we did on the other one there. We'll do that one first. I'll just hold the capacitor into position. We'll snip the leg. And then we'll bend it across so it's over where it's lifted. And we'll solder that into place. That was a little bit annoying, that. Again, that was my fault. As I pushed it through, I should have been watching on this side, watching it come through, and I didn't. And it caught the pad as it come through and lifted it as it come through. And so then the hole was definitely clear, so it weren't as though I hadn't cleared the hole and it pushed it, lifted it up as it come through. It just caught on the side of the hole and just flipped it. So it's not the end of the world, that, because it was an easy one to remedy. It's just a little bit annoying. Just give them a quick bend out so it holds into position while I solder them. There we go. What we can do is we can just slightly lift them, just make sure they're seated at 100% like that. Yeah, I'm happy with them. Take a tad more solder to that. A tad more solder to that. There we go, happy with them. And just snip them off. Right, so that's the two main smoothers there replaced. So we're onto the low voltage stuff now at the back here. Now this, I think, is what's basically the most critical to get them voltages as good as they can be. We'll start with this one here, which I think is like 100 UF. I know I've got one. I know I've got every one of them, so we'll start with this one. We'll get this one out. might have to add a little bit of fresh solder. It's crystallising a bit on that. A tiny touch of fresh. Oh, that's it. Let's see if we can get that out now. We'll give it a little rock as we bring it out. That side's out, it's just this side here is holding it. There we go, we're out. We'll just give them holes a quick suck. Make sure they're nice and clear for the new capacitor to go in. There we go. And they're both free. Yep, they're both free and clear. And we are replacing a 100 UF at 25 volts. Get the new capacitors out. There we go. I've actually gone with 100 UF at 50 volts to get something at least equating to the size of the old capacitor. What have I just done with it? There it is. Look, that's the old there. That's the new, and I had to go up to a 50 volt rated capacitor just to get something equating on size. So anyway, we'll get this in. Again, fortunately the positive is marked. Why aren't you going through that hole? You're nice and free. Right, we'll just give that a quick re-suck, because that's not going through there cleanly. There we go. Hopefully that should go through this time without a problem. Let's give that a quick and push that home like that. There we go. And we'll solder that into position. And I have just noticed, I've just glanced up and noticed I've only got about 5 minutes left on this memory card that I've got in the camera. So what I'm going to do, just finish this one capacitor here. I'm going to stop filming, sort my memory card out, and go and have a quick comfort break, and then we'll be right back at this. So hopefully, like I said, it'll only be a second or two for you, but I'm just going to have a few minutes away from the desk, so back in a second. Okay, we're back, and I'm all fed, watered and everything sorted out, and I've got another, well, over an hour on this card, so I think we'll get this video finished in this take. Right, so we've replaced the usual suspect capacitors down there. We've replaced the two high voltage DC electrolytics there. We've changed that little 100 UF capacitor down there, so let's move our way along the board. So seeing we're changing them all, we'll pull this one out next. This is a, I think it's 1000. Yeah, it's 1000 UF at 16 volts we're taking out next. So hopefully my iron's heated back up. Let's give it a quick try. Yeah, that's fine. In fact, I think what we'll do is we'll just add a little bit of fresh solder before we suck these out. There we go. And a little bit of fresh solder on there just before we have a suck away. Let the heat penetrate and a quick suck. Same on this one. Okay. I think this one will just need another go at it. I think we'll have to just lift. Just use the screwdriver just to lift that leg up. There we go. That's up. Same on that side. The problem with this is because it's in bigger capacitors, the legs are a little bit thicker, so it's not quite as easy to get out the board. So we'll give that another quick suck. It's a real pain, the fact that they bend the legs over when they solder them in place. It does make getting them out that little bit harder. Let's have a go at that. Just heat that while we pull it through. That's that side. Now I'll have to be a bit careful doing this one because I don't want to risk trying to push that through and damage the trace there. Give that a quick final suck just to get rid of some of that excess solder. That's better, and the same on this one. Should really have a little bit of solder wick for doing that, but I haven't got any. On me. That's just holding on in that one back leg there. So let's go in with the iron again. Come on, out you come. There we are. It's gone. So that's the old capacitor out, and yeah, it's a 1000 UF at 16 volts. That can't remember where I went up very slightly on the voltage rating on the 1000 UF ones. I think I might have. Let's have a look in here. And again, these are a good quality. I think they're Panasonics. But the good quality capacitor. These are 1000 UF at, in fact, is them the ones are, those are a cheap one. No, yeah, sorry, it is these ones. These are the Panasonic ones. So again, they're very slightly different form factor than what we've taken out. We are going to have to do a bit of leg bending, I think. I thought we'd get away with it, but no, we're not. At least they're the same height, but like I said, obviously that's a 16 volt 1000 UF. The replacements are 25 volt 1000 UF, and if you look height wise, actually they're pretty much the same. But if we look at them that way on, you know. Right, let's get this in anyway. So positive that way, negative that way. Let's push that down onto the board. We'll solder that into place. Right, now on there, solder that side, and there we go. We'll snip them off. That's another one done. Right, let's move across. I think the next one's 1000 UF as well. In fact, yeah, we've got 2000 UF there. We've got another 100 UF down there, and then we've got that 2200 UF to do there. So let's do this 1000 UF here. In fact, I'm going to add a little bit of extra solder to these just to help us get them out. So the new fresh solder helps the old solder to flow, basically. Makes it a little bit easier to get it off the board. Heat that up, come in with the solder sucker. That was a good one. We got most of the solder off that one. Again, heat that up. Give it a quick suck. Got some crud stuck on there, but again, we've not done bad there. We've got most of the solder off them connections. But what we will have to do again is just heat it and try and lift these. So a bit tricky to do this because basically you've got to lift it while it's hot, so you've got to get the soldering iron and the screwdriver in contact at the same time. Oops, lifted a little bit then. There we go, get that up. Once you've got it up, it's a lot easier just to whip the last little bit of solder out as well. If you need to, you might just be able to slide it out. Some of these can definitely be, there we go, that one's up. A little bit tricky when they've bent them right over like that. I have come across these power supplies where they haven't been like that, so I wonder if it was down to whoever assembled them. Right, we should be able to get that out. Heat it up that side and just rock it. There we go. That side's out. Just there we go, that's out. Oh, I think that capacitor was a little bit poorly. One of the legs has literally just dropped off it, and if you look at all that brown gunk around there, that's definitely not been a happy capacitor. In fact, we can even see even more so on this side. We'll just prop the board up and I'll zoom you in so you can see. Oops, wrong way. You see that horrible big stain there on the board? A big stain right there. That was corresponding to the bottom of that capacitor we've just taken out. And it's actually still got, oops, let me get this so you can see. It's still got the leg of the capacitor actually stuck there in situ. So we'll have to do something about that. Fortunately, because we've got the leg set up there like that, it should be fairly easy to get out. In fact, if I heat it up, we might be able to just push it through. There we go. We'll give that a quick suck just to get that. Oops. Helps you prime your. Let's get it so you can see what I'm doing. There we go. Just heat that up and give that a quick suck. There we are. And spin that over. We should be able to. There we go. You can see that. And we should be. There we are. That's out now. I can just spin it around my finger. Out you come. And what I will do is I'll get some a cotton bud and a bit of isopropyl, and I'll just give that area there a really quick little clean up before the new capacitor goes into position. Because like I said, that's all dried electrolyte that's leaked from that electrolytic capacitor. Like I said, it's obviously been leaking quite bad. So let's give that a clean up round there while we're in. Ugh. Ugh, that is horrible. Just give that a quick scrape. It's actually stained the fiberglass. That. Give it a quick scrape and a final clean. Yeah, it's left the fiberglass stained a tiny little bit, but at least most of it's come off, and you won't really see that when we stick a new capacitor in there anyway. So I'll zoom you back out a bit. You can see me work. This is another of these 1000 UF. Like I say, we're going slightly higher on the voltage rating. Being these are, like I said, these are 25 volts, and the old ones were 16 volts. we seem to have actually worn off the... Yeah, let's just check this out there. We seem to have worn off the printing on the board there that showed us which was positive, but we can just look on the old capacitor. There we go, through, push that in, get that to seat properly. There we are, that's the new capacitor in home. And where's my solder? There's my solder. There we go. Okay, so that's the that's that 1000 UF in there. So we've got one more 1000 UF to do there. We've got that 100 UF, and we'll leave the 2200 till last. I think we'll do that 100 UF in there next, which is that one there. I think it's this one. Let's just double check. Yeah, it's this one. Alright, let's see if that's free. Should be. Yeah, that's free. Let's get that under and winkle the little bugger out. At least that side's free. Right, we'll just need to give that a little suck on that one. There we go. Let's get the capacitor out. Out you come. It's just being held on there. Just being held by a thread on that side there. We'll just try the old heat. Just give it a quick heat up trick. That should. There we go. It's out. So that side's out. Give that one again, just heat it up a little bit. That's the capacitor out. And we'll just clear that hole so we're ready for the new one to go in. There. Oh, no. That's what we'll do. Just get a little bit of fresh solder, seeing it's being awkward. Put a bit of fresh solder on there. Go back in, and that's it, nice and clean. Right, that's another 100 UF, isn't it? There it is. Another one of these. Keep that straight. No, not that one. Another one of these. Okay. Just make sure we're putting that in the right way. No, that way around. Put that in there. Push it home. Flip it over. Okay, that's that one done. That's that one done. Snip these off. There we go. We've only got two more to do, and that's all the caps replaced on this board. So we've just got that one and that one to do. We'll do that one first. fact, we'll do what we did before just to make life easier, and we'll just add a little bit of fresh solder to them two connections. In fact, we'll do these ones while we're in here because that's the other capacitor we're going to be taking out. Right. Let's start with this one. Heat it up. It's got most of that off there. And heat it up. And that's got most of that off there, but we're going to have to do what we did before and just so we can lift these pins up slightly so we can get the capacitor out. Bend it up. This one should be a bit easier. There we are. Make sure you keep the joints hot while you're moving that, because otherwise you could risk tearing something. Right, so once we've got them lifted up, we can just take any excess solder away. Make it a little bit easier to get it out of the board. That's that one. And that one. Hopefully we can get that easily out of the board now. Let's give it a try. Yeah, that's free. Just being held on by a thread, I think. That side's completely free. You can see it moving around there. It's just being held on by a thread. Just try and walk that out the board. So a bit of heat can help. Side's out. That side's out. That's it. There's the capacitor out. Don't look in too bad a condition, but we need to go. Right, we'll clean these legs up and we can put the new part in. Warm that up. Give it a quick suck. There we go. Right. This is the last 1000 volt to go in. Sorry, not 1000 volt, bloody hell, 1000 UF to go in. Just goes down there. Right, solder them in place. Like that. And snip off these there we go. So all we've got left to do is that one there, and we'll get that out, and then we'll give a bit of a test and we'll see if actually changing all these electrolytics has made a difference. I'm actually expecting it will have, especially considering we had one that had obviously got a major defect in it. You know, it had leaked and basically one of the legs broke off it, so that can't have been much of a capacitor anymore. Right, are you going to come out easy or not? No, again, these ones, they've really bent the legs over and they're quite thick ones, so we'll have to just heat up and just lift the pin up, then we can obviously get it out the board. Oops. There we go. There we go. There we are, up. Now I'll get a bit more solder away from them joints. In fact, what I'm going to do, because they were quite long, them legs, I'm actually going to snip them down while they're on the board like this, just so I can get the... I mean, that one's free, but are they going to come out? Oh, actually, yeah, we have just got away with that. Again, I think that one has started to leak. There's definitely some residue around that negative terminal of the capacitor there. Let's have a look at the board there. That's absolutely fine. Yeah, and there's a bit of crud on the board there, so I will just get the isoprop out again. I'll just have a really quick little wipe round that part of the board just before I put the new capacitor in place. And like I said, then we'll clean the table up a bit, and we will give the board a quick test. And give the board a quick test after that, and then we can reassemble it. But we'll just give around here a really quick clean up first. There we go. Not quite as much crud's come off that than the other side, but still a little bit's come off. Right, let's get the new capacitor in there, which is here. $2,200 UF. I think I went for exactly the same voltage rating. Where's the old one? No, that's 16 volt, and again we've got up to a 25 volt. I said you can't really go down in voltage rating when you're installing these capacitors, but it doesn't matter a jot if you go up a little bit. I mean, you could go up a lot, it'd still work, it'd just be a massive waste. But if you go up a small amount, you're just giving yourself that little bit of extra headroom on the component, really. And being that these components, like I said, they've got smaller with years, if you go with a slightly higher voltage rating, it might actually physically fit the board better than the same voltage rating as the original. Solder that side in place. Do the same on that side there. Again, I'm happy with that. And snip that, snip them legs off. In fact, I'm just slightly out on that side. I've just a little bit skewed. It's just not just slightly seated. So I'm just gonna go back in. I'll just hold the capacitor. I'll just slightly reheat that and just give it a little tweak like that. Perfect. Righty ho. Clear a bit of space on the desk. Make sure we clear it. In fact, what we'll do is we'll make sure we clear away all this dross. So I'll get the new spare new capacitors out of the way. I'm going to just hold on to a couple of these caps we've taken out, and we're going to do a quick test on them and see quite how bad they are. Oh, and I found the one that I'd lost before. I was sat on it. But never mind, listen, the one that I actually fitted is probably a slightly better quality component anyway, so I'm not worried in that respect. Let's just get something to clean all this crud off the table though. Right. I'll stick them over there for testing. There's no point testing that one. That one's not going to test very well with one leg on it. Oops. Oops, oh dear. It's all going wrong. It's all going wrong. There we go. Back on there. Right, let's finish off just doing a quick tidy up. Just want to make sure we keep the bits we need, like the fixings, the screws and everything to put it back together. Don't want to lose them. In fact, what I'll do is I've got a little packet here. I'll stick all them in a packet. Right. 1, 2. I think I'm missing a few there. Let's just make sure we've got everything we need to have in the right place before we go any further. There's the switch. There we go. I think that's all the bits. There's our I'm just making sure I'm not going to sweep up all the screws and what have you when I get rid of all the muck and rubbish on the table here now. Let's give this a quick sweep. The reason I'm doing this is we're going to be powering that board back up, and I don't want anything on the desk that could be construed as something it could short on, so that's why we're having a little bit of a tidy up there. There's the other 2 screws I wanted. So that's all the screws in that bag, ready for us to put it back together. And we'll get the board back out, and we'll do make absolutely sure there's nothing metallic underneath it. This is leather, so it's fine as a insulator, at least for what we're doing here now. Let's find that. Where's that crock lead I had before? What have I done with it? Let's find another one. Right, got a crock lead. That's where the crock lead I had before. It's still connected onto the bloody thing. Never mind, we'll use that one again. We'll connect that up there. It just gives us an earth. We'll take the switch. Just connect the switch up. So what we really want to see is, have we made any real difference to the output voltages by changing all those capacitors. Right, so we're all connected up there. I'm happy with that. All the new capacitors are in place. I think they're all the right way around, so we shouldn't have any magic smoke fun going on. We'll get you back onto what we're working on. Right, so we're all set up as we were before. Let's get the meter in so we can have a look. Can you see that? No, you can't. Can you see that? Yes, you can. Right, we'll connect that up to there as a ground point, like that. Set that back down to 20 volts. I think we're all connected up there. We can plug this back in. We'll just connect that up to there just so we can see. I think that should be switched off, but just to be on the safe side. Right, plug that in there. Here we are, switched off. I will have to move that just while I quickly switch us on. Okay, and it's telling us we've got 5.5 volts on the 5 volts DC rail. That's fair enough. What I'm curious, 5.4. What I'm curious at is see exactly what the minus 5 volts is at now. So let's see if this has come up any. A tiny bit. It's still quite low, that. But like I said, my other BBC supply is very, very similar. The minus 5 volts is not quite getting to minus 5 volts. And I'm wondering if that's just an inherent thing of these supplies. Right, let's check some of them other voltages though. Again, 12 volts is about where it was, 11.43. 5 is exactly as it should be. Like I said, that should be exactly the same, -4. It's come up a tiny little bit, but it's still not a solid -5. I think that's probably just inherently down to the design of the power supply. I think, like I said, my other BBC Model B power supply, which hasn't really been worked on, the only thing that's been done to that is the very basic thing of swapping out them X2 capacitors which blow. I think that, and possibly that 220 UF capacitor has been changed in it. Can't remember whether I did that or not actually. But apart from that, it's not been worked on at all. As well, this one, like I said, we've now put all new electrolytic capacitors in it. At least, I mean, the good thing is it should have future-proofed it for another 20-30 years, but it doesn't seem to have made much difference in actually bringing the voltages up in it. And I can't see anything else in there really which is causing an issue, so I think it's a case of because it's my other one's working, the bead works, we'll have to just say that that's okay. Then voltages are alright. The 5 volts, which is the important one, is bob on, you know, that's absolutely fine. I'd just like that -5 volts to be that tiny little bit higher, but it's hardly used for anything. I think there's a couple of ICs that might need it. Anyway, what we'll do now, we'll get this thing put back together, so at least the video's complete and you've seen me literally do everything, oops, excuse me, everything how to rebuild one of these power supplies. So let's get this all disconnected, because we'll have to disconnect this again obviously, at least these 2 wires, so we can reassemble it in the case. So, and yes, I do have it unplugged, don't worry. Definitely unplugged. Right, let us look at putting this back in there. Let's get these the spares out of the way. It should just hopefully just literally slide back in, because we don't have the switch in situ. I'm not worried about touching this thing now. We've already ascertained that there's a bleed resistor on these capacitors, so there's not going to be any charge in them. And slide that in. And get it sat on its mounts. Let's get the earth back round where it should go. This can be really the fiddliest part sometimes, is putting the damn things back together in the case. Right, let's get the screws. Where's my screws? There's me. Where's the other ones? Oh, they're there. So that's 2 of them, I think. Those are the correct screws? Right. I think we've got a full set of screws here. Right. That is right, okay. It's a case of just making sure you get the right screw in the right hole, because they are slightly different. The screws for the 2 earth tabs there that have the nut on the back are actually slightly different size, a slightly different diameter to the screws that hold the board down like that. Right, that's the first one in. We have to also make sure we get our little washer on there as well before we put them in. Oops. Where's my magnetic one? Oh, we'll try this first. Oops. Go on. Getting some of these screws back in can be more fiddly than doing some of them capacitors. There we are. Up you come. Oh. Right, where's my screwdriver that's magnetic? If at first you don't succeed, cheat. Get the washer over the hole. The washer's stainless steel, so it's not really very magnetic, so that's easy enough to place over the hole. And if we get the screw in the screwdriver, drop it down the hole. And it's just a case of getting the thing to... There we are, we're in. Screw that in tight. There we are, that's that one in. We've got one more to go down in this corner, and then we've just got them we've got the earths to just reconnect, and basically we're there. Right, last one of these. Go on. There we go. There we are. That way in. Now we've got... I seem to have a nut gone AWOL. I'll have to see if I can find that nut wherever it's disappeared off to. Because we need that. Just trying to get a bit of the locking compound off them screws because it's not making it easy. But anyway, we'll get this one in first, and then we've got that one down there. In fact, no, we'll do that one first because then we can carry on putting all this back together. And I'll see if I can find another another nut for that. Put that in there. Right. There we go. Put the nut on the back of it, and hopefully we can get that in. Just hold it with my finger until we get it started, and then I'll have to go with the other pliers, I think, to do it up. Oh no! Oh yeah, we'll need the other pliers just to finish that one off. Okay. Oops. Get hold of that. That's nice and tight. And put the power connector back through now. Now we need to push it through and give it a quick pull and a tug, and it'll lock back in place, like literally a reversal of the process we've just done. Right, let's get the switch connector back up. And we can get the earth back through there because the earth's going to connect back to that lug around there as soon as we've found the what we've done with the slightly embarrassing what we've done with the in fact the switch should be that. Should the switch be, no, the switch, that's right, isn't it? Yep, that's right. Push these wires through and connect them back onto the switch. Like that. Push that back into position. This should just literally just click back into position. like that. Lovely. That's gone right back in nice and easy. So that's the switch back in. All we need to do now is just reconnect these, that earth and that earth to that lug there. We've got the screw. All we need to do is find out what on earth and it's in there. This silly bugger. There's the thing. So we put the screw through. Put the first of them lugs on in position. Put one of them washers on. Put the next lug on. And put the nut on there, and then we just need to tighten that up. Let's get hold of that and tighten it nice and tight. There we go. And that's it. That's the power supply with all new capacitors in it. So it should be good for another 20 or 30 years. Just to give it one last quick test. We'll plug it back in. Now it's all back in its case. Where's my tester gone? What is there? Just sit that there so you can see the display on it. Switch that on. I'll just connect this up so you can see. We should have a nice 5 volts here. Just best testing before we actually use it in anger. So we just connect that back up like that. We'll give it a quick final test. Yeah, and there we're happy. We've got our 5.0504 around there voltage. So the only thing I would have liked is if we'd have brought that up a little bit, but well we have, because it was about 4.3 something, weren't it? We brought it up to 4.4 something. But I would have liked it if it had been closer to these -5. It's close enough. And again with the 12 volts, we're just that little bit low there. I'm not worrying about it. Like I said, my other one is exactly the same. It's a little bit low on the 12 volts and it's a little bit low on the -5 volts. Anyway, basically that is how to do a full recap on one of these Beeb Model B BBC Micro power supplies. So, is it worth changing all these capacitors in it? I mean, these are all the ones we took out. So these are all the capacitors, apart from that one which I can't show what I've done with now. Oops. Yeah, that's really what I needed. Knock my keyboard over. So those basically, and another one which has gone AWOL, that one with the leg had dropped off. These are all what we've changed out. Now, that one is actually starting to dome ever so slightly. Not hugely, but that is just about starting to dome. That's one of the 250 volt 100 UF capacitors. That 2200 UF from the end, it's actually got physical signs of leakage underneath, so that has actually started to leak physically, so that really did need changing. These little 1000 are the 100 UFs. Actually, none of them show any sign of leakage, and I'm pretty sure if I put them on a capacitance meter they wouldn't be far off but for what they cost and the fact we're doing them all, there's no point leaving them in there. 1000 UFs, well, that one's started to leak. One had obviously leaked quite severely because the leg literally fell off it, and one seems okay. So it swings and roundabouts. You know, if you want to keep your beeb in working order, really, you know, something like that. I mean, it's not bad actually. I've got quite a lot of stuff over the years from Retro Computer Shack. They're not bad. Yeah, I'd say definitely get one of them. Change the 2x2 capacitors, and like I said, that 220 UF is a good call to change. Whether you want to change them, the big DC smoothers, them 100 UF 250 volt ones, they're only about £1.50 each, and they do start to fail. They will probably solder on for quite another few years, but like I said, that is starting to dome there. They're probably worth changing. All the capacitors in this, and considering I bought enough to do 2 power supplies, it was under £10, and they're not cheap, nasty, no brand capacitors. They're all Panasonic, you know, they're good quality capacitors. So, in my view, yeah, it's well worth just spending that little bit of extra time and just doing all the electrolytics. You know, it's really, you can just see it as you future-proof the power supply for another 20, 30 years. So anyway, I'm going to leave it there for now. I hope you enjoyed that little update on Project Mildrids Ashtray. So thanks for watching. Apologies, this is probably going to be a ridiculously long video, but I hope you enjoyed it, and I hope you enjoy waiting out for the next one. So thanks for watching, and goodbye.